Okay, so I want to discuss now how we're going to use the calculator to calculate binomial probabilities. And essentially there's 5 different kinds of questions. I'll go into each one. So for the first example, I discussed in the previous video about flipping coins. So suppose a coin is flipped 10 times. Find the probability of exactly 6 heads. Okay, now we're going to use the calculator, and I made up a chart for these questions. And so the first thing on this is probability of exactly X successes in N trials is binom PDF NPX. So this is going to be a binom PDF NPX, and your job is to identify the N, the P, and the X. The N is the number of trials, so that's 10. Number of trials. The P is the probability of success, and the X is the number of successes. So in this particular example, the N is 10 for the 10 flips. The P is 0.5 for the probability of success. That's the probability of flipping a head. And the X is 6, which is the number of heads we want. So on the calculator, we're going to go binom PDF 10, 0.5, 6. Now on the calculator, the binom PDF is a distribution. I'm hitting second, and the distribution is above the vars there. And you have to arrow down to get to binom PDF. There it is. Okay, my stat wizard is on. So it prompts you, the number of trials is 10. The P is the probability of success, which is 0.5. The X value is 6, the number of successes. And when I hit paste, that's what you'd get if you had the stat wizard off. And it comes out with an answer about 0.205 to 3 decimal places. 0.205. Just let me show one thing about the stat wizard. That's in the mode. Your calculator might be a little bit different place in the calculator, but if I arrow down to the stat wizard, see on, off, I can turn it off. And then when I go do the same thing, distributions, arrow to binom PDF, see, then it doesn't give me that menu. I'm supposed to know what to enter. N, P, X, and of course it spits out the same thing. I'm going to put the stat wizard back on because it can be helpful because it prompts you for the values. So when you're first learning this, it might be helpful to have the stat wizard on. Okay, now let me do another example. Let's suppose that, let's get away from coin flipping. Let's say the probability that Wilt makes a free throw. I'm talking about basketball, and the free throw is a binomial trial. Either you make the free throw or you don't make the free throw. And the probability that Wilt makes a free throw is, say, 0.509. And the question is, find probability Wilt makes at most 3 of 7. So this is a little bit different question. I'm not asking exactly, I'm asking at most 3 of 7. So on the calculator, well, first I'm going to go back to my chart. And on the chart here, it gives what to do. Probability of at most X successes, this is number 2, is binom CDF NPX. This is binom CDF NPX. Now the C there means it's going to accumulate all the probabilities of 0 through x. This is again the trials. This is the probability of success. And for CDF, this adds up the probabilities of 0, 1, 2, etc. up to n. So it kind of accumulates the probabilities. So when we ask for that Wilt makes at most 3 of 7, when we put a 3 there, it's going to add up the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. In this example, we're going to use binom CDF. N was the number of trials. It was 7 free throws. The probability of success was 0.509, and we want to accumulate the probabilities up to 3. Notice it's NPX. On the calculator, I'm going to the distributions, and this time, careful, I'm going to binom CDF. The number of trials is 7. The probability of success is 0.509, and we're going to accumulate the successes up to 3. And it spits out an answer about 0.480 to 3 decimal places. Okay, now here's another kind of example. Suppose probability of finding a pearl in an oyster is equal to 0.341 of 5 pearls of 5 oysters. Find probability of less than 2 pearls. Okay, again, our job is going to identify the N, the P, and the X and look at the chart correctly. So for this one, it says the probability of less than. So this is number 3, the probability of less than X successes, binom CDF N, P, X minus 1. So we're going to subtract 1 from that 2 pearls. So this one is going to be binom CDF N, each oyster is a trial. The probability of success is 0.341. And it said less than 2 pearls. And the chart said to subtract 1 from that, X equals 2. So we're going to put a 1 here. And on the calculator, that comes out binom CDF 5 trials, 0.341, and we want to accumulate 0 and 1, so I'm putting a 1 there. And I get a result of about 0.446 to 3 decimal places. Okay, here's another kind of example. Probability, let's go to Steph makes a free throw, is 0.903. Find probability that Steph makes more than 9 of 11. So the question is asking for more than 9 of 11. On the chart, this is number 4. It's going to be 1 minus binom CDF NPX. So this is going to be 1 minus binom CDF N. There's 11 free throws. The probability of success is 0.903. And the number of successes we want is more than 9. On the calculator, 1 minus, notice I'm entering that 1 minus first, binom CDF, 11 free throws, probability of success is 0.903, the number of successes we want to accumulate up to is 9, paste, and notice I'm going 1 minus binom CDF, and that gives out an answer of 0.710 to 3 decimal places. 710. Another question, or Or another type of question. There's 5 of these altogether, and this is the 5th one. Is something like this. Suppose probability the Leafs win a game is 0.526 of 6 games. Find probability Leafs win at least 3. Now, I think this is the 5th item on the chart. Probability of at least X successes, 1 minus binom CDF N P X minus 1. So this is going to be 1 minus binom CDF N is the number of games, which is 6. The probability of success is 0.526. And it said X minus 1, so the X is 3, so X minus 1 is 2. And on the calculator, I'm going 1 minus binom CDF, 6 for the number of games, 0.526 is the probability of success, 2 is how much we want to accumulate up to. So notice I have the 1 minus thing going on there, and that comes out with a probability of about 0.704. Okay, so those are the 5 kinds, but in the homework they asked this question, and I just wanted to do this example also. Okay, here's the last example. So in a batch of 5,000 batteries, the failure rate is 2%. A buyer accepts a batch if of 50 there are 0 or 1 defective. Find the probability the batch is accepted. So this one, the N is 50 for the number of batteries. Actually, it's the failure rate, that's the probability of success, is 2%, which is 0.02. And if there were 0 or 1 defective, we could say that the X is at most 1. At most 1. And so this can be answered as the probability the batch is accepted is binom CDF 50.021 binom CDF 50.02. We want to add up the probabilities 0 and 1, and that comes out to be 0.736. 0.736 to 3 decimal places.